Hello everyone, welcome to the class. This is the 7th video on gas laws. Okay, in today's class we will be solving numericals based on combined form of gas laws. In 6th video I have taught you numericals based on Charles law. Okay, so if you refer your book, and we are in exercise 7. Okay, the questions that I solve here is from exercise 7 of your book. So before that, I'll give you the formula of combined form of gas laws. Combined form of gas laws says that P1 V1 upon T1 is equals to P2 V2 upon T2. P1 is pressure, V1 is also V1 is volume, T1 is temperature. Okay, temperature in Kelvin scale, and P2 is pressure, V2 is volume, and T2 is temperature. Okay, in second case. Okay. First question is from exercise 7. Okay, you refer your book for questions. What will be the minimum pressure required to compress 500 decimeter cube of air at 1 bar to 200 decimeter cube, temperature remaining constant? Temperature remaining constant. Okay. So here is the question. What will be the minimum pressure required to compress 500 decimeter cube? So this is the volume V1, okay, of air at 1 bar. 1 bar means pressure. P1 is 1 bar. To 200 decimeter cube, this is V2, volume, okay. Temperature remaining constant. Temperature is constant in this case. Okay, solution. Given V1, first volume in first case is decimeter cube, dm stands for decimeter, and this cube. Okay, pressure P1 is 1 bar, V2 is how much, 200 decimeter cube. P2 pressure we have to calculate, and it is said that temperature remains constant. Okay, temperature is constant. Temperature is constant. So in this case, instead of using this formula combined form of gas laws, you can directly use Boyle's law. P1 upon V1 equals to P2 upon V2. Okay. Otherwise, you can use the same formula. So temperature remains constant means let T1 is equals to T2 is equals to some constant K. Okay, let it be this. Let the temperature be K. Or let T1 equals to T2 equals to T. Let it be T. Because temperature is kept constant means whatever is the temperature in first case, same is the temperature in second case. Okay. So I'll use this formula, combined form of gas laws, directly. Okay. By combined form of gas laws, we have P1 V1 upon T1 is equals to P2 V2 upon T2. P1 is how much? P1 is 1. No need to put the unit. Okay, unit is same for both this V1. V1 is 500. T1 is, we have considered T. Okay. P2 we have to calculate P2. V2 is 200. T2 is T. So this and this gets cancelled, T and T gets cancelled, two zeros gets cancelled. 1 into 5 is 5 is equals to 2 into P2. So from here 5 by 2 is equals to P2. 2 goes down in the denominator. Okay, then it implies P2 is equals to 5 by 2 means 2.5. Therefore the required pressure, required pressure, write it properly, okay, is equals to 2.5, and you have to put the unit of pressure. What is given? Unit of pressure is given bar, VAR bar. This is how you have to solve. Okay. Otherwise, in this case, since temperature is constant, you can directly use Boyle's law instead of using this. Okay, that also I'll show you. So or, okay, this is or by using using Boyle's law, B-O-Y-L-E, Boyle's law. Boyle's law says that volume is inversely proportional to pressure. That means V1 into P1 is equals to V2 into P2. This is the mathematical form of Boyle's law. Using this mathematical relation, we have done so many numericals, okay, in previous classes. So V1 is how much? Put the value of V1, 500 into P1 is 1 is equals to V2 is 200 into P2 is we have to calculate. 0 0 gets cancelled, 5 by 2, this 2 goes down, okay, P2. Therefore pressure is equal to 5 by 2 means 2.5 bar. This formula, since because temperature is TMP, okay, temperature is kept constant, so you can use this also. Now let's move on to another question. Question number 2. Okay, question number 2 is 2 liters of a gas is enclosed in a vessel at a pressure of 760 mm of Hg. So given 2 liters means volume, V1 is equals to 2 liters, pressure P1 760 mm of Hg, 760 mm Hg, okay. If the temperature remains constant, temperature is kept constant, so you can directly use Boyle's law. Temperature is kept constant means you can directly use Boyle's law, okay. P1 V1 equals to P2 V2. Calculate pressure, we have to calculate pressure. P2 we have to calculate, it is said T is equals to TMP, okay, temperature TMP is constant, temperature is constant. Calculate the pressure, P2 we have to calculate when the volume changes to 4 decimeter cube. V2 is equals to 4 decimeter cube. Now look at here, V1 is given in liters and V2 is given in decimeter cube. You have to convert these two values into same unit, okay, either convert it to liters or convert it to decimeter cube. So this I'll convert it to liters. It will be 4 liters, LTS, liters, because 1 decimeter cube is equals to 1 liter. 1 decimeter cube is equals to 1 liter. 1 decimeter cube is equals to 1 liter, okay, so 4 decimeter cube will be equals to 4 liters. By using Boyle's law, that is P1 V1 is equals to P2 V2. So put the value of P1 is how much? 760 into V1 is 2 is equals to P2. We have to calculate V2 is how much? V2 4. So 760 into 2 divided by 4. This 4 goes down, okay, is equals to P2. Do the cancellation. 2 1 2, 2 2 the 4, 2 1 the 2, 2 3 the 6, 2 8 the 16, 0 the 0, 380. It implies P2 is equals to 380. Therefore, required pressure is equals to 380. What is the unit pressure given? mmHg, okay, mm of Hg. This is your answer. It is very, very simple, okay. Now let's move on to another question. Question number 3 and 4, it is a different question, okay. Question number 3 is different, so let's move on to question number 4, okay. Okay, question number 4. Question number 4, I'll not write the question, okay. 800 centimeter cube of gas is collected at 654 mm pressure. Full stop. At what pressure would the volume of the gas reduced by 40% of its original volume, temperature remaining constant? Okay. So you refer your book for the question. So given is 800 centimeter cube of gas. So V1 volume is 800 centimeter cube. gas is collected at 654 mm pressure. So P1 pressure is 654 mm. Pressure is 654 mm. At what pressure? P2. We have to calculate P2. Okay. At what pressure would the volume of gas reduce by 40% of its original volume? V2 is original volume. V1 minus 40% of V1. Reduce means you have to subtract. At what pressure volume will be reduced by 40% of its original volume? V2 will be V1 minus 40% of V1. Okay. So let's simplify this. V1 is 800 minus 40 divided percentage means divided by 100 of means into V1 is 800. Okay. So this and this gets cancelled. 800 minus 40 into 8. 4 is 32. 320. It will be how much? 320 will be 0. 8. 7 minus 3 is 4. 480. 480 centimeter cube. Temperature remaining constant. T in temperature is constant. Temperature is constant. So use Boyle's law. By Boyle's law, P1 into V1 is equals to P2 into V2. Put the value of P1. P1 is how much? 654 into V1 is 800 is equals to P2. We have to calculate V2 is 480. So from here 654 into 800 divided by 480 is equals to P2. So 0 0 gets cancelled. You cancel the remaining things. Okay, and you find the answer. Your answer will be 1090 mm of Hg. Answer is 1090 mm of Hg. Cancellation you do it on your own. Okay. Otherwise you can cancel like this. 8 6 are 48. 8 6 are 48. 8 10 are 80. 6 1 are 6. 6 1 are 6. 6 0 are 0. 6 10 are 60. 6 9 are 54. So 10 into 109 will be 10908 equals to P2. Therefore, required pressure is equals to 1090 mm of Hg. This is how we need to solve. Okay. Now let's move on to another question. Now question number 5. Question number 5. A cylinder of 200 liter capacity contains a gas at 100 atmospheric pressure. Okay. Full stop. How many flasks of 200 centimeter cube capacity can be filled from it at 1 atmosphere pressure, comma, temperature remaining constant? Okay. Given a cylinder of 200 liter capacity, volume V1 is 20 liter capacity, 20 liters. Volume is V1 is 20 liters. Contains a gas at 100 atmospheric pressure. Pressure is 100 atm, atmosphere. Atm stands for atmosphere. Okay. How many flasks of 200 centimeter cube capacity? V2 is equals to 200 centimeter cube. Small flask. There is a big cylinder of 20 liter capacity. Okay, and small cylinders are there of 200 centimeter cube capacity. So how many such cylinders, these small cylinders, can be filled with this gas? Okay, 20 liters. First of 200 centimeter cube capacity can be filled from it at 1 atmosphere pressure. P2 is equals to 1 atmosphere. Temperature is what is said? Temperature. Temperature remaining constant. Temperature is constant. Temperature is constant. So this volume is given in liters and this is in centimeter cube. We have to convert it to same units. Okay. Our relation is our relation is 1 liter is equals to 1000 centimeter cube. So 20 liter will be equals to how much? This you note it, okay? 1 liter is equals to 1000 centimeter cube. So 20 liter will be 20 into 1000 centimeter cube. I have converted it in centimeter, okay? 20 into 1000 centimeter cube because of this relation. Now let the number of cylinders filled is equals to x. Let the number of cylinders filled be x. Then by Boyle's law, BL, I'll write BL short form, you write it completely, okay? Boyle's law, you write it. By Boyle's law, P1 V1 is equals to P2 V2. P1 is how much? P1 is 100, V1 is 20 into 1000 is equals to P2 is 1 into V2 is V2, where is V2? 200 into X. You have to do, we have to do into X, because from this big cylinder gas is poured into small cylinders, okay, in X small cylinders. So total volume of this will be equals to X into 200, okay, because there are X small cylinders. So X into 200 you have to put this. So you put star here, you might forget this part, okay, this one, because each small cylinder is of the capacity 200 centimeter cube, and total there are, we have considered X cylinders, so total volume will be 200 into X, okay. From here 100 into 20 into 1000 divided by this 200 goes down, okay, 200, and here in right hand side you are left with X only. 0 0 gets cancelled, 2 10s are 20, so it implies 100 into 10 into 10, 10,000 is equals to X. Therefore number of cylinders filled, FILLED, filled is equals to 10,000. 10,000 cylinders can be filled, okay. Now next question number 6. Question number 6. A steel cylinder of internal volume 20 liters is filled with hydrogen at 29 atmospheric pressure. If the hydrogen is used to fill a balloon means only one balloon, okay, at 1.25 atmospheric pressure at the same temperature, what volume will the gas occupy? Given a steel cylinder of internal volume, so V1 is given 20 liters. 20 liters is given, okay, is filled with hydrogen at 29 atmospheric pressure. So P1 is 29 atm atmosphere. If the hydrogen is used to fill a balloon at 1.25 atmospheric pressure, P2 is 1.25 atmosphere atm. 1.25 atmospheric pressure at the same temperature is kept constant, okay. What volume? V2 we have to calculate. Temperature is constant. Temperature is constant, okay. So use same formula, Boyle's law. By Boyle's law, P1 into P1 V1 is equals to P2 V2. P1 is how much? 20 into 29 is equals to P2 is 1.25 into V2. So you cross multiply it. 20 into 29 divided by 1.25 is equals to V2. This 1.25 goes down here, okay. So remove the point from denominator. 20 into 29 divided by 125. When you remove the point, this point is in hundreds place, so 100 will go down. Okay, you can write this 100 here, it will go up. When you remove a point from numerator, it goes down in denominator. Okay, point value goes down in denominator, and when you remove a point from denominator, the point value goes in numerator, is equals to V2. Now you do the cancellation. 25 4s are 100, 25 5s are 125, 25 1s are 5, 5 4s are 20. So V2 will be equals to 4 4s are 16 into 29 will be how much? 16 into 29. You do the multiplication. Okay. Okay. V2 16 into 29 is you do the 16 into 9. Okay, 464 might be liters. 464 liters is your answer. Okay. Now next question, question number 7. 561 decimeter cube of a gas at STP. STP means standard temperature pressure. Okay, is filled in a 748 decimeter cube container. So V1 is given, V2 is also given. If temperature is kept constant, calculate the percentage change in pressure. We have to calculate the percentage change in pressure. Okay. Question number 7. 561 decimeter cube of gas at STP standard temperature pressure is filled in a 748 decimeter cube container. If temperature is constant, calculate the percentage change in pressure required. Okay. So given B1 volume is a 561 decimeter cube. V2 second volume is 748 decimeter cube. Pressure P1 is not given, P2 is not given. Okay, so it is said STP. It is said STP, standard temperature and pressure. Means standard temperature is 273 Kelvin and standard pressure is 1 atmosphere. 1 atmosphere or 760 mm of Hg or 76 centimeter of Hg. So you can write any of these three values on the pressure P1. So for simple calculation, I'll write 1 atmosphere instead of this and this. Okay, to simplify easily. So 1 atmosphere, because it is said STP, standard temperature and pressure. Standard pressure is 1 atmosphere. Now let's find P2. Okay, and then let's calculate the percentage change in pressure. So by Boyle's law, since temperature is standard, constant, okay, P1 V1 is equals to P2 V2. So P1 is 1 into V1 is 561 is equals to P2. We have to calculate V2 is how much? V2, where is V2? 748. If you cross multiply, this goes down in denominator. P 561 divided by 748 is equals to P2. Okay. Now change in pressure. Change in pressure. Change in pressure. Which is bigger? P1 is bigger. 1 is bigger than 561 divided by this. Okay. So P1 minus P2. P1 is how much? P1 is 1 minus P2 is 561 divided by 748. If you do the LCM, 748 is the LCM. This will multiply here. 748 into 1 is 748 minus 561. Okay. If you subtract this, 8 minus 1 is 7. Okay. 14 minus 6 is 8. 1 divided by 748. Can you cancel this? 5 times. 6 times. Okay, you cannot cancel. So let it be that only. Okay. So we have got 187 divided by 748. Okay, 4 times 4 7s are 28, 4 8s are 32, 30 34, 4 1s are 4 5 6 7. Okay, you can cancel 4 times. 187 1s are 187, 187 4s are 748. So 1 upon 4. Therefore, percentage change in pressure. Percentage change in pressure is equals to, your question was to find the percentage change in pressure. Okay, so formula is net change divided by original pressure into 100%. This is the formula for percentage change. Okay, like profit percent. Formula for profit percent is net profit divided by original price, or CP, into 100%. Similar formula is there. Okay, net change is 1 upon 4. Original pressure is P1. 1. Original pressure means this is P1. Okay, into 100%. This will be equals to 1 by 4 into 100%. 4 1s are 4, 4 25s are 100. So 25%. This is your answer. Net change in pressure is 25%. Okay. Next, question number 8 is 88 centimeter cube of nitrogen is at a pressure of 770 mm mercury. If the pressure is raised to 880 mm, find how much the volume will diminish. Temperature remains constant. Question number 8. 88 centimeter cube of nitrogen. So given V1 is 88 centimeter cube, okay, is at a pressure of 770 mm mercury. Pressure P1 is 770 mm of Hg. Refer your book for the question. Okay, 770 mm of Hg. If the pressure is raised to P2, okay, new pressure is 880 mm of Hg. Find how much volume will diminish. V2 we have to find. Okay, net diminish in volume we have to finally we have to find this V1 minus V2. This net diminish is how much? This we have to calculate. So for that, let's first find V2. Okay, temperature is constant. Temperature is constant. So use Boyle's law. By Boyle's law, P1 V1 is equals to P2 V2. So using this formula, find V2. Okay, once you get the value of V2, suppose V2, once you get the value of V2, you write it. Therefore, net diminish, D-E-M-I-N-I-S-H, diminish in volume. Net diminish in volume. Net diminish in volume is equals to V1 minus V2. V1 you put the value, this 88, minus V2 you have calculated from this equation. Okay, and then you subtract it. That will be the final answer. Okay, now next question number 9. Question number 9 is a gas at 240 Kelvin is heated to 127 degrees Celsius. Find the percentage change in the volume of the gas, pressure remaining constant. Okay, this much for today's class. The remaining questions, this question number 9 to question number 15, 16, I'll teach you in another video. Okay, so thank you. You complete your works and send it to me. Okay, this much for today's class.